In this video, we're going to talk about drawing the graph of a quadratic function written in vertex form using what's called the step pattern if the a term multiplier equals 1. And at the end, we're also going to state the transformation of each function. Now, to begin, I want to discuss the parent function of a quadratic function, which is y equals x squared. The parent function of any function begins at the origin, which is at 0, 0. And that just so happens to be the vertex of this parent function. 0, 0. If we consider this written in vertex form, which you've already learned about, there is no h or k value, and so if there isn't a number that exists or doesn't exist, then it's 0. So we've determined that the vertex is 0, and that's going to be the first step of all of this process from now on. You always base these graphs off of their vertex, and then when you state the transformation, you compare the new vertex to the vertex of the parent function, and that'll help you see how it's moved about the x and y axis. So first step, we found the vertex. Second step, we're going to use the step pattern to draw the parabola of the function. Now the step pattern is based off of the first 3 perfect squares, and I'm going to show you what I mean by that. So if I put 0 into this function, and then 1, 2, 3. I'm going to make a table of values. But I input an x value of 0 into this equation right here, y equals x squared, I will get y equals 0 squared, and 0 squared is 0. And if I put 1 in there, I would get y equals 1 squared, and 1 squared is 1. If I put 2 in there, I get y equals 2 squared is 4. And then if I put 3 in there, I get y equals 3 squared is 9. So if you notice, yes, the first 1, 2, 3 perfect squares, 1, 4, and 9 are what we're working with, and that's going to help us build out the step pattern that we're going to use. So if I want to draw or plot these points that exist in this function, I would begin by starting at the vertex, 0, 0. I'd go over 1 and up 1. That's the first point. And if you remember, parabolas or quadratic functions are even and symmetrical. So whatever I do to the direction in the right, I have to do to the direction in the left. So I go over to the left 1 and up 1 as well. And that makes sense because if I put negative 1 into this equation as well, I would get y equals negative 1 squared. Remember, you have to square that negative as well. And a negative 1 times a negative 1 becomes a positive 1. So I would go over to negative 1 and up to positive 1. So the math works out as well. So I can plot 1, 1. Now I'm going to go over to 2 up to 4. And then over to 2 up to 4 in the left, the negative direction. And then finally over to 3 up to 9. And then over 3 up 9. This is the parabola, or the graph of the parent function y equals x squared. Symmetrical about the point x equals 0. Now, the step pattern then, that we're going to use to help remember how to draw these things very quickly. We're going to base it off of what each dot has done in reference to the last one. So if we start here, all right, at the vertex, we're going to go over 1, and then, I'll use a different color, over 1, right, we traveled over 1, and then we traveled up 1. So we go over 1, up 1. And then actually, I'm going to switch, we're going to switch all of these to over 1. I want to do it a little bit different way. So please make that correction on your paper. So we go over 1, up 1. And now we are here. Different color, come on. Now we're here, all right? And then from this dot, we go over 1 again, which is right here. And then up 1, 2, 3. Over 1, up 3. And then finally, we're at this dot, and if we go over 1 again, we go up 1, 2, 3, 4, 5. Over 1, up 5. So the step pattern then, If you can remember that you go over 1 from the previous dot that you've made or point that you've made, you go up 1, up 3, up 5. And again, it's based off of the perfect squares. Because if you bring it back to the vertex, you go, the first move you make is over 1, up 1. And then if you go back to the vertex again, the second move you make is over 1, 2, up 4. And then if you go back to the vertex again, it's over 3, 1, 2, 3, up to 9. So either way works. This is a little bit easier to remember, so I'll reference the step pattern up 1, 3, 5 when we're talking about this. All right? So that's how you draw the parabola of any quadratic function. And that's how you draw the parabola if it's given to you in standard form too, but we'll talk about that later. So I'm going to actually show you the expectation of this objective. If you were given a problem like this on a practice assignment or a quiz or a test, this is how I'd expect you to do this. Especially if it said, draw the graph and state the transformation. So I'm going to do the first example. And it tells me it's y equals x minus 2 squared plus 4. So the first step I'm going to do is find the vertex. Always, always, always find the vertex. If you remember, here's the power. To the left is the h value, and it's lying to you. To the right is the k value, and it's telling the truth. And h and x go together, k and y go together. So the h value is -2, but it's lying to you, so it becomes +2. And the k value is telling the truth at 4. So the vertex is 2, 4. So I can go ahead and plot that. Now, the second step is to use the step pattern that we just came up with from this new vertex. So again, it's as simple as going over 1, over 1, over 1, and up what it tells me to do up here. So the first thing I'm going to do is go over 1, up 1 in both directions. And then I'll do over 1, this one right here. I'll do over 1, up 3 from the new point that you made. So over 1, up 1, 2, 3. Over 1, up 1, 2, 3. And then finally from these two new points, I'll do over 1, up 1, 2, 3, 4, 5. A little bit of an estimate. Over 1, up 1, 2, 3, 4, 5. Yeah. And then I will connect my points. And this is the parabola of the function y equals x minus 2 squared plus 4. So, second step, we use step pattern. I'll put to draw. And then the third step then is to state the transformation that this function made based off of the parent function. Here's the parent function up here. We're going to state how this function that I just did moved based off of the parent function. And again, I'm going to look at the vertex. The vertex of the parent function right here is 0, 0. So horizontal movement, remember, is the x value, or the h value. And vertical movement is the k value, or the y value. So this shifted then from the parent function's vertex, it shifted to the right 2 spaces. So I'm going to write that out in a complete sentence. Let's use some math words. How about the parabola shifted right 2 spaces some more room here. So it shifted right 2 spaces, and then remember the y or the k value is vertical. It shifted right 2 and it shifted up 4. Right 2 spaces and up 4 spaces. And I'm done. So this would show me, if you were to show me all those steps and you were able to draw the parabola correctly, that would show me that you completely understand this objective of drawing the graph if given a quadratic function in vertex form, especially if you're able to state the transformation. So go ahead and pause the video and try your example on your own, and then check your work with mine afterwards. Please check your work with mine. Here's the graph of the parabola. It shifted left 4 spaces and down 2 spaces because remember, the h value of the vertex is always line 2. So it was positive 4, it shifts to negative 4. So I found the vertex, I drew the graph based off of the step pattern, and then I stated the parabola shifted left 4 spaces and down 2 spaces. That would have earned you all of the credit for this objective. Now, keep in mind that this is how you draw parabolas when the a term is 1, right here. When the a term is 1, I suppose I should have stated that at the beginning. But if you look here, there is no value, and if you look here, there is no value. So that means that a equals 1 when there is no number listed in front. In the next video, you're going to learn what happens when the a value is not 1. Right here. So if you look, yes, the a in that case is 2. The a in this case is negative 2, and so on. So just keep that in mind moving forward. Thank you.